today, welcome to our workshop. My name is Alex Sin. I'm in AI Software Solutions here at Intel. I'm here to give you a hands-on workshop on how to get started with our Intel Gaudi AI accelerators. This will be a two-part workshop. First part, we'll be covering fine-tuning LLMs and inference on this platform. A little bit about me. I graduated from UCLA. My background is in embedded and computer systems. So I started off doing embedded software development for about 3 years before coming over to Intel. I did system validation on our Xeon CPUs for about almost 2 years before transitioning into my current role. Nowadays, I act as a technical consultant to customers to enable and debug all their problems so that they are happy and successful in building their AI applications. I also spend time delivering webinars and workshops like this to teach you how to use our AI software tools. So for today, this is what I have planned for the first part of our workshop. I will just give you an overview of what are some of the challenges that our developers and customers are facing when it comes to fine-tuning and doing inference with LLMs. And all the red items are the ones that will be hands-on for today. So we will be covering how to use our GPU migration toolkit. We'll be also doing fine-tuning a Llama 2 model and then doing inference on it. So if you haven't already, please go open up a web browser, go to the site up to the port number, up to the comma, and then enter in the password so that you can log into a Jupyter Lab session. All right, and now this is the first hands-on part I wanted to show you. So once you've logged in, you should be able to get something that looks like this, something similar. But go ahead and click on this plus button. Open up a terminal right here. You should get something like this. And then I want to introduce you this command called hl-smi. HLSMI is very similar to the SMI for GPUs. What it does is it gives you information about the utilization, the memory utilization of your cards. And here is no different. So here, for example, I just want to point to you that it shows you the driver version. So right now it's using 1.15.1. And you can see there is just a single row for one card because all of us only have a single card right now. But a typical Gaudi server has 8 of these cards plus 2 Xeon CPUs. So if you were to have your own entire Gaudi server, you would actually see numbers 0 through 7. Gives you information about the power usage, the memory utilization, and also the compute utilization. AIP stands for AI processor. So when you're actually running your fine-tuning or inference, you should see this 0% be a non-zero number. Okay. And so what is Gaudi? So some people, how many of you have heard of Gaudi? How many have heard it for the first time? Everyone else. Okay, so most of you is new to this. So you all familiar with GPUs already? Now, Gaudi is not a GPU. It is an AI accelerator. It's a custom-made chip that's in its sole purpose is to do deep learning training and inference of the largest models out there. So we're talking Gen AI models. We're talking LLMs, models that have 50 billion parameters or hundreds of billions of parameters. These are the types of models that Gaudi can run on. It has, and how does Gaudi compare to, or how we position Gaudi is, it's competitively priced performant. What that means is based on what you pay for, you get a certain amount of performance that is competitive compared to the competition, which is the H100 and A100 GPUs. Number 2 is that it is scalable. So this is a Gaudi card right here, and if you can see on the top and bottom, there are these green ICs. These are integrated Ethernet ports. What this allows is we're able to connect these Gaudi cards directly with these Ethernet ports without having to go through an external NIC or network interface card. And why this is good is because it reduces that overhead, it reduces power and costs, and you get very good scaling efficiency. Whether you are scaling up from 1 card to 8 cards or scaling out to multiple server racks. And another thing I want to mention is Gaudi 2 uses 100 gigabits per second Ethernet. Gaudi 3, which is our upcoming next generation of Gaudi, will have 200 gigabits per second. So it will have double the network bandwidth. Our launch event for Gaudi 3 will be next week, September 17th. So keep a lookout for the announcements that our CEO will make about it. The last one is why we're here today. It's easy to use. Our engineers have developed a lot of software libraries and a software suite. And my job today is to show you that how to get started with Gaudi. So first, let's start with priorities and challenges with regards to working with LLMs. So when you're working with LLMs, you want to work with these models that to perform a specific task, whether it's Q&A or code generation, summarization. We also want to create something that's valuable to the customers that are going to use your product in the end. But it comes with those challenges, which is development of this is a very expensive iterative process. Whether you have to continue to fine-tune your models or you need to maybe use RAG to make sure you have a good vector database of the information that actually solves your customers' problems. And part of that is having high-quality data. The second, once you've developed the model, you have to do inference for deployment. And so you want to ensure that it provides value to your customers. That is the end goal, and you also want them to have a good experience. But challenges include meeting those SLAs, so performance like latency, or you need to have enough throughput. You also have to be able to maintain its quality over time as you serve more and more customers. So how can we resolve those pain points? Well, we want to reduce the time it takes to train those models. You want to be able to work with different foundational models to be flexible in your application. And overall, you just want to continue to improve the high-quality data that you have to best serve your customers. So how can we do that with Gaudi? So there are 3 places where you can get started working with Gaudi. The first is called model references. These are models that our engineers have pre-optimized, everywhere from ResNet or Stable Diffusion, BERT, many of those models that we've already been working with. That's a great place to get started. We also understand a lot of customers are working with transformer models, especially from Hugging Face. How many of you work with Hugging Face models? Okay, just a couple of you. So if you don't know what Hugging Face is it's a library and also has a large repository of transformer models, models like Llama, models like Falcon, and it performs all different tasks, whether it's Q&A or summarization, code generation. And what we have here is it's a library called Optimum Habana. This acts as an interface between Gaudi and Hugging Face, but the extra part is that it's going to compile those models into graphs so that you can execute these models in an optimized fashion. Otherwise, by default, in PyTorch, your models run in what's called eager mode. that means it's running like operator after operator. Versus graph mode, it creates a computational graph of your model. And Gaudi is able to perform your convolutions or perform your inference, perform your training at much more efficiently. The third item is the GPU migration toolkit. So we understand most customers and developers are using GPUs already. We want to make it seamless for you to transition to Gaudi, or at least try it out. See if you get the performance you like. And so actually, we will work on this. Our hands-on portion will cover this tool very shortly. So GPU migration toolkit, how does it work? Essentially, what it does is you already have code that runs on CUDA, for example. Now, all you have to do is a couple line code changes. And what's going to do is, during runtime, replace that Python code with code that works on Gaudi. And so this brings me to the first hands-on portion of today. So if you are in your Jupyter lab, you should already have a folder called Gaudi Tutorials. Go ahead and navigate into PyTorch, single card tutorials, and then open up that model migrate single.ipynb. So I'll do it up here as well. So Gaudi tutorials, PyTorch, single card tutorials, and then model migrate single. When you open it, you should get something that looks like this. Okay. And just really quick, can people in the back see this screen okay? Perfect. Does anyone have issues navigating to this notebook? Oh, sorry, I cannot hear. You don't see the folder? Go back. So what you want to do is go back. Oh, okay. Thank you. Yes, please help each other as well. This is supposed to be more of a discussion, and also yeah. And so here, this is what the notebook would look like. And let's start with a clean slate. Let's run the first cell, which is exit. And you should see a message saying kernel restarting. We just want to make sure the kernel's clean, so it's not running anything else. And let's go ahead and run this next cell. So this is cloning the model references repository. And one thing you want to note is that it's cloning there's a -b 1.15.1. And this is super important because earlier I mentioned our software suite version and driver version is 1.15.1. For Gaudi, we do need to install the corresponding version of the library so that it is compatible. And then run the next cell as well. This is just going to navigate into the example we're going to run. So this is the PyTorch examples GPU migration computer vision classification one. The example here is just going to do training on ResNet, but we're not actually going to train ResNet. I just wanted to show you how the GPU migration toolkit actually works. So we're going to skip that. Go ahead and run the next cell as well. This cell right here just shows you in the training script what the imports look like. So the only one I want to point out is this one, import Habana frameworks.torch.gpu migration. So we import that. And the second step is in the following cell. What you need to do here is you need to add htcore.mark step after you call your loss.backward to do backpropagation, and also right after you do your optimizer.step. And that's it. That's all you have to do to get started with this GPU migration toolkit. Import the library and also mark the steps for backprop and optimizer step. Then we can go ahead and actually run the actual training. So this is so it's not actually going to run. So I just want to point out here that you see here we're running the training script. We still specify device equals CUDA. This is to mimic how you would normally run it on a GPU. But the cool part is if you scroll down, what it's going to do is go through your code, and whenever it finds code that refers to CUDA, it's going to automatically replace that with code that works with Gaudi. HPU stands for Habana Processing Unit, named because Gaudi was originally developed by Habana Labs before being acquired by Intel. And so you can see, like, it's not just when you set the device, also when you do distributed, it's a one-to-one mapping between the two. Another one I want to point out here is, so here the back end is using NCCL. It found it and is able to replace the back end to HCCL. HCCL stands for Habana Collective Communications Library. And so yeah, the takeaway of this is you don't have to make many changes to your existing code that runs on GPU to get started running on Gaudi. Any questions? Yes?
What if you do not provide that device equals CUDA option in the query? Is it still going to run?
Are you asking if your code does not have torch dot?
Yeah, basically.
Yeah, so how the tool works is it's only going to replace whatever it finds in your code during runtime.
Okay.
Yep.
Mine failed, but I don't know.
Oh, so it's supposed to fail because we didn't download the data set.
Okay.
Yeah, so it's supposed to do training, but we don't have enough storage and time to download ImageNet 2012. The whole point of this is just to show you how the GPU migration toolkit works. Great, so now let me go back to the slides here. Okay. So additionally to the three libraries I talked about, model references, Optimum Habana, and also the GPU migration toolkit, we also have a lot of other open source libraries that support with Gaudi. Two of them I want to mention is TEI Gaudi and TGI Gaudi, stands for Text Embeddings Inference and Text Generation Inference. I will actually be covering that in the second part of this workshop. That's usually used for building RAG applications. I also want to give a highlight to the OPEA project. So OPEA stands for Open Platform for Enterprise AI. It's a collaboration between Intel and many other companies where we want to make it easy for people to build and deploy generative AI examples and also use a lot of microservices for things like text generation or RAG. Okay, so next topic is going to be fine-tuning LLM. So one of the techniques for fine-tuning is called LoRA, low rank adaptation. One of the problems with training is that, well, one, it takes a lot of storage to load these FP32 models. And when you store these large models, it's also going to take a long time to train it. So what can we do to speed that up? That's where LoRA comes in. You can just really, in a simple way to think about it, instead of training over all of the parameters in the model, we only train on a subset of it, a subset that is still representative of the model itself. And that leads to the second hands-on portion. So for this one, go ahead and you should already be in that folder. Go ahead and open up the Single Car Tutorials Llama 2 Fine-Tuning Inference Single Notebook. Okay, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Does anyone have any issues finding the notebook? All right. So now let's go ahead and run the first cell. So all of your cards, it already has a Hugging Face token pre-installed onto your system. But normally for you, you would provide your own token. Because we are running with Llama 2, you do need to request a token and get access to it. All right. Yeah, this information is more information about what LoRa is. But go ahead and just run this next cell. What it's doing now is we are navigating into the appropriate directory and installing the Optimum Habana library. So Optimum Habana, yeah, again, it is a library that acts as an interface between Gaudi and Hugging Face. And you'll notice that we are installing a specific version because it is based on the driver version we have installed on our Gaudi. If you go to our Gaudi documentation, there is actually a support matrix that tells you, for which hardware platform, which OS, which driver version you need to install the corresponding Optimum Habana library. All right, so once we do all the setup, the next part here is we're actually going to run fine-tuning with LoRa. So that would be this cell right here. Go ahead and kick it off. So just a couple parameters I want to specify. We are running with the Llama 2 7 billion model. We're using the bfloat16 data type. If you're not familiar with bfloat16, it has half the bit width of FP32, but the decimal precision, it only has 3 decimal places instead of 6 to 8 decimal places for FP32. So in a way, because you're using less bit width, you use less memory and you can make these computations much faster. But 3 decimal places is sufficient enough so that we don't lose much accuracy. That is why bfloat16 is so powerful. Couple other items. So a couple other items I want to mention is, for example, we're gonna use Habana. That's how you tell it that you want to run it on Gaudi. So go ahead and let this run. This will run, I believe it will take about maybe 10 to 12 minutes or so. But we're fine-tuning an entire model here in just 10, 15 minutes. That is something that I want to point out. Because usually when you fine-tune models, that could take many hours. But on Gaudi, it only takes minutes. Question?
How many Gaudi cards required to run Llama 405?
1 card. Oh, sorry, Llama
405B, the largest one.
405B. Yeah, 405B has, so that's 400 billion parameters. Okay, so a very large model. So I would recommend using, of course, you got to use multiple cards to do so. But I can tell you for certain that a single Gaudi server board can handle that, because Gaudi 2 has 96 gigabytes of HBM per card. So multiply that by 8. That is sufficient to work with a 400 billion parameter model. Is this running on everyone's notebooks, the fine-tuning? Okay. So while we wait for it to finish, are there any questions so far? Okay. Yep, so while we wait for that, I will just continue with talking more about the slides. So let's talk about inference now. So for inference, you have these 3 challenges that you need to resolve. Cost and ability to scale up and scale down your system. You need to meet your SLAs. So latency, throughput is super important. And of course, maintaining resilient deployment. So maintaining the same quality of service for your customers. You need three things. So first, you definitely need access to hardware and software support. So to address that, we have Gaudi. I mentioned all of the software libraries that we have available to help speed up your performance. We need to have high throughput, low latency. And last but not least, we need to scale. And for scaling, right now we're just working with a single card, but with the integrated Ethernet, you can really scale up to 8 cards on a single server or multiple nodes. Here, I just wanted to show some performance numbers for doing inference on a larger llama model. So this one is for 65 billion. So here, we just wanted to show some numbers when you work in both bflow 16 and the FP8 data type. Yeah, Gaudi does support down to FP8, especially for inference. We are also working with even exploring lower precision data types as well, including int4 and FP4. Also here, we are doing some comparison between 1 card versus 2 cards as well. Okay. Yeah, so the next part is going to be the inference. So this is actually the same notebook that we've been working on. The following cell is we're actually going to do inference on it. But I believe most people is still running. So I'm just going to skip ahead and talk a little bit about our Intel Tiber Developer Cloud. How many of you heard of our Intel Tiber Developer Cloud? No, one person. One person only. Okay, great. So the Intel Tiber Developer Cloud is Intel's own cloud service to give you access to our latest hardware. Hardware that hasn't been released out to be on, so like on-prem or from our OEMs or other cloud services, including AWS. We usually offer here first, while we work with, say, AWS to make that available to everyone else. And this is the best place to get access to Gaudi 2 cards, where you can rent it for only $10.42 an hour. Compare that to the H100 GPU, which is what we compete with. So I remember I just checked. So last year, that price was $96 an hour on AWS. But yesterday I checked, it has gone down to $40 an hour for H100. So you're still getting 1/4 of the cost, but relative performance.
NVIDIA say 405B is running at $10 an hour, and Google say they can run $5 an hour.
$5 an hour. Yeah. So it's based on how we view it, right? So that is when you take into consideration all of the power, that energy bill. Right. Yeah, but right here we're just talking about how much does it cost if you were to rent the hardware, right? So it's a little different.
Right now the industry standard 405B running $10 an hour. If you be below that, you have competitors. Above that, you.
Right. Right, but I'm just referring to like renting the actual hardware. So we got to compare apples to apples. Yes. Yeah, and I also want to, and if you are interested, I have a little QR code here. So if you're interested, you can go to cloud.intel.com, or you can come up here and scan this QR code, or take a picture of this. This is actually a coupon for $250 of cloud credits. So you can use that and spawn your own Gaudi or even Xeon instances, and you can actually run try to run the same notebooks that we're doing today. So be sure to snap a picture of this on your way out. Another way you can get access to and also I forgot to mention, with regards to AWS, Gaudi 1 is available on AWS. I believe the pricing is around $15 an hour. And Gaudi 3, we have a launch event next Tuesday, the 17th. And Gaudi 3 will also be available on the Intel Tiber Developer Cloud very soon as well. The second way to get access to Gaudi is Denver DataWorks. This is another cloud service. That you can use to get access to it. All right, so let's go back to our notebook, see where we're at. Let me zoom out a little bit. Yep, for most of you by now, it should be done. But I just wanted to mention how long it actually took to fine-tune that model. So if you scroll in the logs and you scroll up a little bit, so you can see it took only just under 6 minutes to fine-tune a 7 billion parameter LLM. Now, with this fine-tuned model, we can do inference on it. Oh, does anyone still running, or can we go forward? Still running? Error? Chun, can you help her? Yeah. Yep, so go ahead and run the next cells. That's going to install some requirements to do inference. And then right here, it's going to ask you for a prompt. So let's see, what would be a good prompt? Let's do something like, let's ask an interesting question. Is the Earth actually round? And this next command here is going to run text generation using the fine-tuned model that we worked with. So you notice in the command there are this run generation script, certain options we use. So we use HPU graphs because we want to run in graph mode. Use KV cache or key value cache, also bfloat16. So if you look into this logs right here, yeah, you'll notice that once it loads the model, it does that graph compilation that I was talking about because we're using Optimum Habana to do so. And then it does a couple warm-ups before it actually produces the output. And look, I think that's pretty good. It's not just a theory; it's a fact. Okay, that's good. It's good that our LLM is giving us something that is correct and consistent to our knowledge. Otherwise, I don't know what we would do if the world is not actually around. And right down here, there are some other stats to do. So one thing to note is that it does take there is some initial overhead to do that graph compilation. But once you have that compiled graph, you can do inference much faster. I believe typically for Llama, if you saw in the previous slide I showed you, it's roughly around 39 milliseconds or so, at least for Llama 65 billion. Okay, so that concludes. So that's all I wanted to show you for this part of the workshop. So I think I just wanted to cover some last closing remarks for part one of this workshop. Yeah, so we just saw how Gaudi can be a competitive price performant alternative to GPUs for running these LLMs. We also showed you those libraries that are already available and open source for you to use, model references, Optimum Habana. You can essentially run any PyTorch model as well. We covered the GPU migration toolkit. If you're already running with GPUs, how just 3 or a very few line code changes allows you to run that same code on Gaudi, does that automatic conversion for you. The only thing I didn't cover in this first part is the OPEA Gen AI examples. That's something I will cover in the second part of the workshop. And I did talk about how to get access to Gaudi 2, Intel Tiber Developer Cloud. Don't forget to come up here, take a picture of the coupon code, $250. So essentially, you can run Gaudi for a full day and rerun the same notebooks as well. Great. Does anyone have any questions regarding this first half of the workshop?
Yeah.
Yes?
So in the notebook, the training fine-tuning notebook, I saw that we get access for some more time so that we can maybe deploy a model to Hugging Face.
Uh-huh.
So I just wanted to know how long that is because like, I want to try this out later as well.
So I need to give, so these nodes are actually not meant for you to use after the event. It's just for this event. Yeah.
So it says so in the notebook it says that we get post-session Gaudi. Okay.
Yeah, for the sake of this workshop, I won't, that's the second part is going to be out of scope.
Okay.
Yeah, but if you are interested, you can go ahead and create an account and then get your own Gaudi instance to do so. Any other questions? Yes?
What is the difference between the chipset of Huawei's and NVIDIA Studio or another tool to generative AI?
You're asking the
Chipset.
the chipset.
Yeah, the chipset in your Huawei.
Can you elaborate what you mean by the difference between the chipsets?
Yes, you have two different chipsets. One by the graphics and one by the process. It's for how many chipsets work in the Huawei Studio. I read it's used for data centers for personal uses. It's used for a complete team. Use one item per team or how many. I get confused with the term. How many people work at the same time in the...
Got it. Okay, I understand. So Gaudi is for data center. Right? Wasn't created exactly for the edge or for 1 or 2 people, right? So it is. Yeah, so it's a data center, so technically multiple people can use it at the same time, but of course, but when running the workloads, right? So like when we're doing fine-tuning or inference, only one task can be done at the same time, at one time. Yeah.
Work like a processor.
One per card. So if you were to have 8 cards, you can say, hey, I want these 4 cards to do fine-tuning, these 4 cards to do inference. You can certainly set it up like that. Does that help? All right. Any other questions? Okay. Does anyone need a break? Or we can continue on to the second part. Yeah, take a picture of this and take a picture of the card. So in the second workshop, we'll be covering how to build RAG applications, and I'll go over the OPEA. Yeah, please return those to me. Oh, and please do me a favor, in your notebooks, click, if there's like an exit on it, exit cell, please run that because we want to make sure it closes the kernel and resets it. So I'll show you what I mean. Yeah, so you see the last one is an exit. Please run this cell so that we actually stop the kernel.
Hey, Alex, I have one question.
Oh, yes.
So from the inference output, there is English text output. There's also some kind of
Oh.
symbol, whatever. What that is, we know.
Oh, So the whole point of this workshop is not so much that functionality.
Okay.
The purpose is to show you that it only takes minutes to fine tune it. That is something that you as a developer we have to continue to iterative process to make it better.
All right.
Yeah, this is just for demo purposes and teaching purposes. Hey, thank you for coming.
Thanks for the answer.
Of course. All right. Give me 1 minute. Do you all have access to the... Oh, did Chen just go over how to get access? Okay. All right, so in part 2, the first part is not really a prereq, but it's always better. I always think it's better to know the first parts because you have a better overview. This will be a little more advanced, but not required to know the previous part for this to know this. So for this part 2 of the workshops, I'll be covering more. I'll probably skip the first part, maybe briefly talk about it for our 2 new attendees joining us, and then I will go over, give you the fundamentals of what RAG is, how does it work, and how we can use the TGI and TEI microservices on Gaudi to build these RAG applications. We will have one hands-on portion for this. Okay, so we covered all of these. Oh, first off, there were the 2 attendees. Were you able to log in? Huh? Yes? Okay. I just wanted to briefly show you that when you log in, click on this plus button, press on terminal, and then you should get something like this. And type in this command hl-smi. What this is very similar to SMI on NVIDIA GPUs to give you information about the cards that are being used. So here we just want to note that you want to note down what driver version you're using. For us, it's 1.15.1. This version is important because we need to install the corresponding versions of other software libraries when we're building out our applications. And the matrix that tells you what those versions are is on the Gaudi documentation page. And here, so you can see there's only a single row, which means you only have access to 1 card. But if you were to work with an entire server with 8 cards, you should be able to see numbers 0 through 7. And it tells you information from like how much power is being used, how much memory is being used, and also the utilization. So if you were to do fine-tuning or inference, you should see these values spike up. Okay. So I will actually skip to building RAG-based services. Okay, so how many of you have heard of retrieval augmented generation? Okay, so I see about maybe a little over half of the room, so some of you have not. So think of it as a way to do better inference with your LLMs without having to fine-tune your model. How it works is essentially you start with a prompt you want to give to your LLM. But if you don't use if you just feed it into the LLM, it's just going to give you a result based on how it was fine-tuned. And it's not always the correct answer, especially if you ask something that recently happened. Like let's say if you ask a question, give me a summary of the Harris and Trump debate that happened 2 days ago. LLM wouldn't know because, well, it was never trained with that information. So RAG is something where we can address that. How it works is once you give it the prompt, it's going to it's going to convert your prompt into what's called embeddings. It's just nothing but a vector of numbers, in text, in the number vectors that represent the actual text. And it's going to look through a vector database, and this vector database has the new data that you want your LLM to understand, but in the form of vectors, a bunch of numbers. That's just how computers store information. When you retrieve that, you combine the two to get prompt. You get what's called a prompt template. It's essentially your original prompt in addition to the context, and that context is that information from your vector database. We feed that modified prompt into our LLM and then do inference that way. That is the fundamentals of how RAG works. Okay. So let's dive a little bit deeper how that actually works. Say you have documents of the new data you want. For example, you have a transcript of the debate we have. What we do is we create data chunks out of it, and then we convert them into these vectors. We might also even add some meta tags to them. We store that into our vector database. Second part, this is the actual retrieval part. Take the query, convert it into its vector embedding, and then performs a technique called vector search. So think of it as it's trying to find the vectors inside that vector database that most closely correspond to your prompt. And how it does it, it gives you the top k number of vectors, and then it goes to another algorithm called re-ranking. So you want to rank them in what's most relevant to your original prompt. And then once you combine them two, you have your prompt, and you also have the context that is most relevant to your original query. You feed that into your LLM and do inference as usual, and now you have a response that can actually answer, that's more accurate and can answer the original question. So that's how it works. But what about the actual compute? What hardware should you use to do the vector search, to create those embeddings, to do the inference? So for building the actual knowledge base, building your vector database, it really depends on how much data you have. If you're working with a really small data set, it is sufficient to use, for example, a Xeon CPU to do so. But if you're working with like millions of documents, many gigabytes of data, then you're going to need some more compute. Gaudi would be appropriate for that. Second is when you're actually doing that query and context retrieval part. So for this vector search and all of that, the CPU is actually much better to do it. But it does depend on the size of the database and also the complexity of your vector space. And then the last part is running inference on your LLM. For this, we do recommend Gaudi because Gaudi was custom made to do deep learning training and inference. And you want to be able to meet the latency requirements and also your throughput requirements when doing so. Okay, so this is a summary of everything I mentioned so far. I won't go into all the details, but the only thing that I did not mention is the fourth one, which is production monitoring. So production monitoring is, once you have your entire RAG system working, we still need to continue to evaluate its performance. For example, accuracy. Is it actually giving us the correct answer? Or do we need to add new data or better data, more consistent data to it so that gives a more accurate answer? I always remember the saying, if you have garbage in, you get garbage out. If your data is not good, your data doesn't have the actual answer, doesn't matter how good your compute is, doesn't matter how fine-tuned your model is going to be. Re-ranking. So re-ranking, it tries to find out what are the most relevant information and context corresponding to your prompt. But perhaps you might need to adjust that algorithm as well sometimes. Inference service quality. So this one is continue to look at, very similar to performance as well, and also looking at your inputs and outputs. The last one is guardrail effectiveness. So we know that sometimes hallucinations will happen as well. So if, even after using RAG, you might need to still implement additional guardrails so that we don't get in trouble. Okay, so now we're going to start to build it. And the first thing I wanted to talk about is the text embeddings inference, TEI for short. So this is an actual microservice that's actually going to convert our prompt into, and also our data into vector, into the embeddings itself. And how it's done is it actually uses a model to do so. So right here, it's using what's called the BGE large N version 1.5 to do so. Takes in text, gives you an output that is just a vector of a whole bunch of numbers. And we have Docker containers to support that. So all we have to do is to build or retrieve that Docker image and launch it. And there we have our very first microservice. Oh, and one way to validate it is to use the curl command. Like pass in a sample input, what is deep learning? And then I will show you in the hands-on portion that once the output you're going to get is what is deep learning, but in the representation of a vector. The second part is TGI, text generation interface. So this microservice is going to actually, is the last step in RAG, where it's actually going to do the LLM inference. It's also runs on Docker. So here, this is just a sample command to do so. One important thing to point out is the model that you're working with. So here, we're just working with the Llama 2 7 billion chat model. Okay. And right here, I just want, this here is for running the TGI, there's actually some additional environment variables that are specific to Gaudi. And these are recommended so that you get the best performance. The ones I want to just specify is the first one, Habana visible devices. That just tells Gaudi which cards you want to work with. So you can specify all will use like all 8 cards, or you can do, hey, I just want you to run this on cards number 0 to 2, or I want you to run this on card number 4. So you have, this is the way of how you can customize what you want to run on each card you have. Another one I want to mention, skip down to the fourth one, is enable HPU graph. This one is super important if you want optimum Habana to compile your LLM into a graph so that when you execute inference, it will be much faster than the default eager mode. The parameters on the bottom is based on how you want to configure your model. So in this example here, where we want to use the Llama 3 8 billion instruct model, you can also specify your input, output tokens this way. Okay, so this brings to the hands-on portion. so let's go ahead and go to, it should be in the same folder you're already at. Single car PyTorch, so it's Gaudi tutorials, PyTorch, single car tutorials, RAG on Intel Gaudi single workshop version. So let's go to that notebook. You should get something that looks like this. Is anyone having issues finding this notebook? All right, so if you're here, go ahead and run the first 2 cells. So this one it's going to install the requirements, but it's also going to ask you to exit. It does need to restart the kernel so that it picks up all of the previous requirements. Yeah, so if you get this kernel restarting after, this is normal and expected. Yeah, the rest of this notebook here, this first part gives you more technical details, everything that I just explained to you in the slides itself, but feel free to review it and use it as a reference. Okay, so in here, this cell right here is going to be initial setup. And here, I'm going to have to ask you to actually make a slight modification. So you see this line here, unique RAG application name. So because we're going to be creating Docker containers and we are, in a way, sharing a lot of the cards, I do need to ensure that everyone is creating a unique Docker container name. So go ahead and enter in your first and last name, followed by, and then do underscore RAG. And then go ahead and run this cell after you've made that modification. So what this is going to do is, first it's going to load this stored Hugging Face token. It's also going to assign random port numbers for our TGI service, our TEI service, and the PG vector database port. That's the vector database we'll be using for this session. And one thing to note is, please only run this cell once for this workshop. If you run it again, it's going to give you different ports, and that is going to make the rest of the notebook not work for you. Okay? So does anyone have any issues running up to this step? Okay, great. Then we can skip over this next one. This one is just if you need to hard code some ports. Well, go ahead and run this next cell right here. This one's just going to install Docker. And once you install Docker, go ahead and also run the next cell. This one is going to pull the TGI Gaudi Docker image. And I'm going to come around and see if anyone has issues with this one. If it's not downloading, let me know. Okay. Let me get the door. Everyone okay with is it downloading? Okay, perfect. And then when someone's done downloading, can they raise their hand so I know, just so I know when, okay, I see a couple hands. All right, go ahead. All right, great. So when it's done for you, go ahead and run the next cell as well. This is going to be You're going to run the actual Docker container. And also run the next one too, Docker logs. That's just going to give you some information about it. And this is to verify that we've successfully run our TGI Gaudi Docker container. All right, so that is our first microservice, the text generation inference. The following cell right here, this is going to test it. So to test it, we're going to use send a request to it. So go ahead and run it. And let me make sure. Okay. Oops, looks like I got an error. Let's see if I can fix it. So when people are running that command, that next box, are you able to get a response? No? No response? Okay. Is it giving an error about something about make request? Connection reset. Is it this? Is this the error? Oh, okay. Connection aborted. Connection reset by peer. Replace with localhost, you said? Yeah, we. Not set correctly. Yeah. Or I can just type in, that's 2 TGI port, 9386. Let's try hard coding it. 9386. Wait, so what you did was you just hard coded it here?
I did that same thing.
Just this? Just did this, right? Okay.
Yours is 9386.
Yeah, so whatever you got here, you just hard coded it? Okay. So somehow it didn't get set properly. Okay. That's odd. Okay, so then if we rerun it, and then if we run it again. Okay, now we're, okay. All right, that is strange. Huh? Port number mismatched. Okay. That is strange because these notebooks are read-only, so every time it's refreshed, it's back to the original. And I ran this workshop 2 days ago. So, but we are engineers. We are here to debug problems and fix things and make them work. So yes, this is the output from our text generation interface. You can see where I got the why is the earth round from the previous part of the workshop. So yep, that's how we verified this is working. Second part is going to be the text embedding interface, or should be inference. So go ahead and run this next cell right here. This is going to pull and run the TEI Gaudi Docker image. go ahead and run the next 3 cells as well. This third one here is to test that it's working. And the input is what is deep learning. And the output we get is a whole bunch of numbers. Why is a whole bunch of numbers? Because this is the vector representation of the sentence, what is deep learning? This is what's going to be used to convert your query into vectors, a vector, and then use that vector to do the vector search in your vector database to do retrieval. Is everyone able to run up to this step? Okay, all right. Or if any errors. Okay, perfect. The third item is our vector database. So we're using the PG vector. So go ahead and run pull and do the Docker run. And if anyone has an issue, please raise your hand or just let me know. Okay, and next is the data preparation step. So for this application, we're going to be using LangChain. So go ahead and run the cell to import all of the required modules, and then run the following cell as well. So this is going to load all of the documents. Oh, if you get this collection not found, it's not an actual error. So don't worry about this one. And then go ahead and also run this cell right here. What this is going to do is it's going to load all of the documents we have into the vector database. And specifically what that data is it's inside this folder, rag/data. So if we go inside rag, go inside data, you'll notice that there's a file called stateoftheunion.txt. So this stateoftheunion.txt is essentially a transcript of some information. We want our RAG-based application to take into account information from this document. And when you're customizing and building your own RAG applications, you can always fill up this data folder with your list of text files. So this step will take maybe about a minute or two because it does need to, it's computing all of the vectors from the actual text file. Does anyone have any questions? Yes? What kind of error? Let me take. From import path, no module named LangChain. Okay. Okay, so go up. I think what we need to do is, and then all the other previous steps are fine. Okay, no module named LangChain. So the error is when she's trying to import LangChain, she's getting an error, no module name.
That's weird.
That's not supposed to happen.
Could you do sudo update?
Yeah, we can try adding another cell right before it, and then install LangChain. Pip install. Yeah.
We need exclamation mark because it's a bash code.
Question, did your kernel crash in the middle or no? No, right? Okay, that's fine. Chung, are you able to help them?
Yeah.
Okay, thanks. All right, I think for most of you who are able to get to this step, you should get the word finished. That's how you know it's completely done loaded into our vector database. Here, we're going to actually run the application. So here, go ahead and run this cell. This cell just has a whole bunch of helper functions. For example, like this is a raw prompt. So how it works, how it might look like when we pass it into our LLM is, you are an assistant for a Q&A task. Use the following pieces of retrieve context to answer the question. Use 3 sentences maximum and keep the answer concise. What we're going to do is it's going to create an app. We type in a question of our choice, and then it's going to append the context of it in the background, and then use this entire prompt to feed into our Llama 2 model. So yeah, the last cell is in section 5. So go ahead and run this. This one will create a nice little widget right here. And it's already pre-populated with the question, give me a summary of the State of the Union. So you can go ahead and press submit. And what this is going to do is it's going to leverage all of our microservices and then generate a response. So I think this is what the output looks like. State of the Union is strong due to the resilience and determination of the American people. Talked about COVID-19. Talked about the Senate passing key legislation, including Freedom to Vote Act, this act, etc. So it's really using all of it is pulling information from this document. Yep. So in summary, for RAG, the part that you really customize is your vector database portion. Whatever data that you need to customize to address the customer problems that you're trying to solve. This is just an example of how you can do that using the TEI, TGI microservices to do so. All right, so that is all of the hands-on portion I have for today. But before we head out to lunch, I'm hungry as well. I know you are too. But I did also want to briefly mention our OPEA, Open Platform for Enterprise AI. This is a collaboration between Intel and many other partners. And first is, and there's 2 components. There's examples and also components. This is an open source project that makes it easy for you to build applications like the one we just did. For example, the Gen AI comps has all of the different microservices. So for example, we talked about vector DB, we talked about retrieval, we got embeddings, LLMs. There's also additional microservices here as well that you can integrate into your application. Yep, so just remember Gen AI comps, OPEA Gen AI comps. But these are microservices for building. We understand that time to production is super important. So what we have done as well is we actually build out Gen AI examples. So these examples leverage at least one of the microservices, and it has several different use cases. For example, so this agent Q&A actually was just added yesterday, or updated yesterday. So this one's very recent. But if for most use cases, you might use something like chat Q&A, so like typing in a question, getting an answer, or even audio Q&A, where you can talk to a chatbot, and then they'll give you a response as an audio output. Code generation, super important. Like we talked, super useful for software engineers and also developers to speed up the coding process. Document summarization, and search Q&A, video Q&A. Visual Q&A is something is similar to using the Lava model. It's a vision language model where you input an image, you ask it a question, and then it gives you a response as a question. Like you can ask about, oh, what's inside this image? Or what is the person in this image doing? So support for multimodal models here. So yeah, this is another place where you can get started. It works for both Xeon and Gaudi. And so this is continually maintained. And what's really good about this is it abstracts all of the optimizations and tools from the different hardware platforms. So you don't have to relearn new tools. You can actually just start with this. It's all containerized, works with Docker, Kubernetes, so that you can easily deploy something to just get something working first. And then you can customize it based on your requirements. All right, so that is all I wanted to cover. I think one more thing I wanted to cover for some of the folks who didn't attend the first half of the workshop is if you are interested in Gaudi, thank you so much, you can get access to it on our Intel Tiber Developer Cloud. Please be sure to come up and take a picture of this card right here. There is a coupon code for $250 of credits, so you can spin off your own instance of Xeon or Gaudi and also run the notebooks that we did today. Gaudi 2 is currently available on our Intel Tiber Developer Cloud for $10.42 an hour. Gaudi 3 will be available very soon as well. And I believe that is it. Yeah, I think that is all I have for today. Yeah, thank you so much for attending my workshop, especially if you stayed for both sessions. I hope you learned a lot about Gaudi, and you can see how it is a viable option compared to GPUs.